Let's dive into my talk. So today I will be talking about the hidden risks within the AI/ML supply chain and how we can secure them, and the tools that have been currently been worked upon within the open source community. And that's the entire overview of the talk. So before getting started, a bit about myself. Hello everyone, myself Yash. I'm currently working as an associate software engineer with Chainguard. We are the team who basically work towards providing zero CV free hardened container images. And addition to that, I'm also a CNCF ambassador and an AWS committee builder. In my free time, I like to play around K8s. I'm in a way of building my own home lab setup. So if you have something to chat about that, happy to have a discussion around that. So yeah, this is a talk overview. We will be going through and understanding how does an AI/ML supply chain tends to look like, how it's different to a traditional supply chain, what's the current threat landscape and the attack surface for the entire supply chain around this, and kind of tools and strategies to understanding how we can basically tackle and try to work around fixing preventing the attack surface which are present, and some final thoughts. So the reason we are here, because it's like in the past 3 to 4 years, there has been significant rise of supply chain attacks, and one of the major eye-awakening attack was like SolarWinds, which happened in 2020. That was like a complete, I can say, a time where basically everyone started thinking security to be one of the critical and utmost thing, and everyone started working towards finding out and creating solutions around fixing this particular problem. There are plenty of, I can say, supply chain attacks I have listed over here, starting from Lotifile, which was like an attack that happened because of maintainers key which got exposed, and apart from that, there are plenty of more, and it's keep on increasing. There is no way attackers will try to stop. There will be more attacks which are ongoing, and they have been increasing in the order as we speak over here. So what does a traditional software supply chain tends to look like? We have a developer, we have a source code, and that particular source code is basically used to build artifacts. At the time of building artifacts, we make use of third-party dependency. For example, if I'm building a Go-based binary, I will make use of third-party dependency to use that, ship it, deploy it to a Docker register, OCI artifact, pull that particular binary and use that in production. But this is how a traditional, I can say, supply chain tends to look like. But if we talk about AI/ML supply chain, it's kind of similar, but there is, I can say, under the hood, there is a subcomponent or like a larger attack surface or area which is like undiscovered. So in the same way, we have ML engineer, we have the model source code. We train that particular model based on the data sets and framework that we tend to have. We deploy that pre-trained model towards a model hub. Then we basically download that and use in production. But if we talk about the critical factor, the subcomponents within this, like a training model, if we focus more towards this, there is an entire bigger picture, because training model tends to have a lot of things. For example, having that raw data, I can say having data pre-processing, where you basically filter out things, add labels, then basically that particular filtered data is used as a data sets to build that or to train that model. As an output of that model, we get a foundational model that can be used as a base model, which can be deployed to Docker Hub. And on top of the foundational model, we can basically fine tune it and the pre-trained model, and basically based on that, we can deploy it in production and use as a customer. For example, I can have a foundational model which is trained on all the languages, and I can fine tune that on one specific use case. This is how an ML workflow tends to look like. But in an ML pipeline, I can say there are various hidden dependencies, and I can say a lot of loopholes, because when we talk about ML and AI, Python is like the language that we tend to use to build this. And when we talk about Python, this is how the entire sub-dependency chart tends to look like. We have application, we have a Python dependency, and one particular dependency, for example, PyTorch, VLM, anything, it may depend on many other sub-dependencies, which may be depending on other sub-dependencies. So in a way, it's kind of a transitive binary tree kind of a structure, where if one of the transit dependency gets impacted or maliciously attacked, it can easily infiltrate into the main application, and our supply chain can be basically attacked. So this is one of the critical, I can say, loophole attackers are trying to find out, because in the past packages have now packages has become one of the prime attacks center for malicious actor to basically work on, because as a industry we have basically have been so strong in securing a production grade cluster through AWS WAF. But now, and rather than attacker rather than focusing on that particular production cluster, they will try to find out the root cause, or I can say the root service that everyone over here tend to use, and in this case it's packages. But in case of AI, in case of ML supply chain, there are plenty of more things. So let's talk about some of the risk within the AI/ML supply chain. First is at the time of data processing. Here, that can be chance of data getting poisoned, where actor can basically tend to add malicious code to the data sets. In a way, you can basically think the model will be working fine, but it can trigger a backdoor attack with some major, I can say, input. So in a way, it's kind of a attack vector that is basically passed on at the initial stage of, I can say, app supply chain. Moving further, there are services like ML as a service component, where basically we tend to use pre-trained models from various cloud providers such as SageMaker, Bedrock, but we are not sure on what particular pipeline or what particular data sets they have been basically built upon. We are blindly trusting that particular thing with a blind hope like it's coming from a trusted source without validating that, and that is kind of a major risk in this particular model training section. Moving further, it's like hub compromise, where in the past there has been various scenarios where package repositories, or I can say hub, has been compromised, and bad actor were able to basically impersonate the original repository, and people were using that particular repository for year-long thing, and after it got investigated. So this is one of the major, I can say, attack surface. Moving further, making use of third-party modules and dependencies. So for example, when we talk about foundational model, once the foundational model is built, we can make use of third-party dependency to basically fine-tune our model. It can be, it comes from various sources, and from there we never authenticate or validate that particular dependency, whether it's coming from trustable source. That can be a, I can say, weakest link within the chain. And once the fine-tuned model is basically, and many of the organization or vendors tend to make use of, I can say, outsource the entire model, or I can say pipeline, to basically make sure they get the end result that they want, but are unaware about the infra on which the model has been trained, or I can say the hardware specification on which that particular model has been built. And in this entire supply chain, anything can get tampered if any one of the small chain, like subcomponent gets I can say attacked, the entire supply chain basically is at risk. So that basically creates a question like, can we trust this model? And the answer is yes and no, because if we tend to follow right protocol like documentation and projects, we will be on a safer side of securing a model. And if that is not the case, then yeah, it's not trust to basically, I can say, trust the entire model that we are basically using. So up until now, we basically had some good understanding about how does AI/ML supply chain tends to look like, why it's different, and what's the difference between traditional software supply chain and the attack surface. There are plenty of more things to talk about. Like let's talk about some of the tools, or I can say community initiatives that have been basically built by a lot of people inside the community. And yeah, so this is kind of a fun meme that I basically added. So anyone can basically secure a supply chain if they have a right set of tools. One of that is basically, so yeah, before moving towards the tool, whenever we talk about securing, I can say, supply chain, we talk about three things. Transparency, where we should be responsible, or we should know from where, what all components or what all things that particular model or particular image tends to have. Integrity, making sure that that particular image, or I can say model, is not tampered. The data set that have been used is coming from a trustable source. And then authenticity, making sure that who basically built that and from where it's coming, like the owner of that particular model, and verifying that in a way so that we are on a safe place, making sure we are using a trustable model into our production inside a dev cluster. So first solution for that, to talk about transparency, is basically SBOMs. The reason I added SBOMs inside AIML supply chain is because there are various AI images such as PyTorch, Triton Server, VLLM, and like securing, there have been, in upstreams, there have been plenty of vulnerabilities, and SBOM is one of the way to basically understand all the, I can say, it's a way to understand all the components and things our container image tends to have. For example, if anyone over here, if people are health conscious, you tend to go to market, you make sure whenever you purchase a food, they tend to have proper ingredients, nutrition facts, and labels. In the same way, if you are purchasing a software, if you are using a software, you should be aware about all the things that particular software should have, and that is what SBOMs tends to provide to us. So it basically provides us all the list of dependencies, versions, all the vulnerabilities that is present inside them, and the license info. This on the left is kind of a diagram where it basically tells entire end-to-end description, like who was the supplier for this particular image, when was this built, what all components that particular image has, does that component tend to have some other sub-dependencies, and all the libraries. So in this case, it may be that I'm using a PyTorch image, and that particular PyTorch image may have 4 to 5 sub-dependencies. So it will basically show me as a dependency tree. I can further validate are the dependency coming from trustable source? If it is, then I can also further validate who is basically creating that, or I can say publishing that particular dependency. So this is what an SBOM tends to look like. And there are 3 formats of SBOM. First is basically XPDS. It's like software, and the entire end goal of SBOM is to basically provide you I can say, a gist of all the things your software has. Each of this, the goal is same, to provide you an entire list. The only difference is the use case. For example, Cyclone Days is basically used more towards compliance, finance. XPDX is mostly used towards legal and all other I can say segment. So it based on the use case, the tools and the format matters, but at the end goal of all the SBOMs are the same. And now let's move forward to another thing. As I talk about SBOM, there is another similar kind of tool which is like AI bill of materials, AI bomb. So it's kind of it's type of SBOM, but it's mostly towards AI-based workloads, so I can say specific to models, because when we talk about models, there are a lot of things: data sets, training codes, I can say software components, and it's way different compared to traditional container image, because in a traditional container image, we tend to have dependency packages, that's all. But in case of models, we have sub-components like data sets, training, libraries and all. And as of now, this is still an, I can say, ongoing work. It was been created. The reason I basically added this over is because it was been presented in one of the research paper published by Google, and they are basically still working on this. And the reason it's not at a mature state is because they don't have a user-friendly documentation, and still it's in work in progress thing. So this is another thing more specific towards I can say models. Moving further, it's like model cards. So this is also been developed by Google. So it's like, it's a standardized documentation where you tend to get all the list of things a model should have. And it provides, for example, the data set that model tend to use, the infrastructure, I can say there's a pipeline that particular model was trained on. Addition to that, I can say limitations on what particular thing that was been built. So there is an example over here. So this is how I can say, yeah, model card tends to look like. It's been developed by Google. And if you see, these are all the models. If we see one of the model like Gemma 3 over here, this is how I can say model card tends to look like, where you tend to have model information, its description, all the inputs like the data set that it tends to use, the output it generates, the citations, and all the data sets, like the pre-processing thing. So whenever as a user, if I'm trying to use that particular model, I can validate and make sure it's coming. It has all the, I can say, pre-check security measures that have been taken to basically get delivered to us. And this is one of the way the community initiative, like people have worked together to basically provide us an gist of things. Whenever you go to Hugging Face, like the model hub repository, you can also see some models tends to have model card, specific, I can say, section where you can see all the list of things and the data set that tends to use. So this is one of the example. And then it's like model scan. So the reason I have added model scan over is because it's one of the open source project, and I came across it through one of the conference earlier, where it basically scans the model and basically help. It's kind of a way to find out is there any I can say tampering that had happened to our model initially at a time of data processing or not. So it's just it's a tool to basically make sure a foundational model, a pre-trained model, are secure and doesn't have any, I can say, vulnerabilities that we want to have. So this is how it tends to look. It's like a command line tool. We can basically execute that in a Git CI pipeline, maybe on GitHub Actions and all. So it's like you can basically scan that particular model, the pickle file, and it basically provide you the list of, I can say, severity, or I can say result, and based on it also tends to validate and showcase you where that particular, I can say, CV, or I can say problem is. For example, this is how it tends to look like. So whenever we make use of model scan, it basically scans the pickle file. It lists all the issues that that the model tends to have, and further at the time of rather than using it in production, we can further go back, try to fix that, and then push it again, make sure it's vulnerable free, and then use it in production. So this is how the model scan tends to look like. And then we talk about model signing. This is one of the cool projects that I tend to love, because model signing tends to come, it's like one of the project, there is one of the project in OpenSSF, a parent org of, it's a parent org within the Linux Foundation that basically works towards all the, I can say, projects within the supply chain. One of the cool and I can say graduated project out of that is SIGStore. SIGStore is basically a tool where you can basically sign any artifacts like cryptographically without any key. And under the hood for model signing is one of the sub-project of SIGStore. So it basically helps us to make sure that if I'm providing a model to a consumer, it's coming from a trustable source, so they can basically validate that it's coming from me rather than any bad actor impersonating character. So this is how it basically works. So whenever I basically initiate it, it's a command line tool in a way. You can also use that in any CI pipeline. So whenever I initiate, I can scan that in model sign and the I can say model that I want to sign with all the credentials. Here it makes use of OIDC token, so you can basically sign through GitHub, Google, or Microsoft, any accounts that you have. So how that basically works in the backend is we have a SIGStore certificate signing authority. In this case, it's Flushio. It basically issues I can say short-lived certificate that that is basically used to sign a model, and that particular data, I can say logs, are further sent to SIGStore transparency log. In this case, it's record. It's kind of a data. It's not a database. You can refer it as a database where all the logs are basically stored. So even if I sign that particular model, and if you want to check, you can go through that transparency logs inside the record and find out each thing. So it's kind of a way you can double verify things. And then finally, you can, as an end product, you get a .sign signature. I can say digital signature on that particular model that you can further push on your Docker Hub or registry anywhere, so that an end user can basically pull that and use that and authenticate it's coming from trustable source like you. So this was the entire workflow about how model signing works. And if we talk about more. If we talk about the end goal, this is how it will look. We have a trained model. It may be coming from any model hub, such kind of Hugging Face. We can scan that whenever we work on models, not like one person tends to work on. There are plenty of teams. So whenever that particular model goes from one team to another, they can make sure that particular model is scanned using model scan. That particular thing will help us understand that that will help us provide a much bigger picture about any vulnerabilities that tends to have. And if it is, we can basically fix that early stage. Once we have a model which is well signed, well scanned, we can further sign that using model signing, where we can add a digital signature, and that particular signature can be present inside our model hub. And then there are two ways we can deploy things. One is like we can use of GitOps. GitOps is kind of an open source tool. So in a way, we can package that particular model and ship it to, and use that particular package to basically push it to a Docker registry. And then same goes for Model Hub. That particular sign, I can say artifact can be pushed to a model. It can be verified through our key, like it can be verified by the end user and by ourselves, making sure it's coming from us, and then it can be used as an interference service in production. So this is how a secure ML workflow tends to look like. I have a demo around this to make sure it's good. So like the reason, yeah, just a minute, yeah. So over here, I do have a, it's not an end goal, it's the model that I used was a basic model, a pickle file, using some pre-trained packages. Yeah. So over here, I'm making use of model scan to basically scan that particular pickle file and make sure it doesn't have any CVs and all. In my case, since I made use of limited binaries and smaller model, it doesn't have any issue. But in your case, it will have. You can go and get any public model on Hugging Face and try to scan that. It will tend to list all, I can say, if it's not coming from trustable source, it will list all the issues under that. Once I have scanned that, I'm damn sure that it doesn't have any issue. I can further work towards signing that using model signing. Yeah. So this is a small command line tool where this it will just a minute. Yeah. Yeah, it will basically, since it will add for OIDC token authentication, so it will create a it will open up a, I can say, SigStore page where you can basically log in and add a digital signature. In this case, I made use of Google. And once that is done, it will that particular, I can say, pickle file, it will be signed by my signature. I can say in this case, it will be my email address, and it will provide me a model.sig file. Further, that particular file and the pickle file, I can push that to Hugging Face, where where along with my data, along with my additional folders and file structure, I can also have my pickle file and my model's signature over there. And once that particular thing is done, we can verify that again with the help of model signing tool. So here we are just deploying that particular signature and our pickle file onto the hub registry. And now we can basically see, we can basically verify that by using model sign verify command, and it will basically, it will provide an output where it will say the key succeed. Just a minute, yeah. So, not sure what's happening. So what we are doing over here is we are verifying that particular pickle file that is present on the Hugging Face model. Here we are referring to our signature that is there, model.sig. It will be present in our, I can say, model hub, I can say Hugging Face. People can pull that, use that signature, and as an identity, since I have made use of my own, I can say Google email ID, I basically use that, and as an identity provider, it will be my Google accounts.google.com, and this will basically provide an success output over here. Verification succeeded. It basically states that that particular model that I basically built is coming from me as a user. In this case, it can be vendors, it can be big tech organizations who are basically working around that. So whenever you basically work on whenever you basically work on pulling any foundational model, or I can say pre-trained model, you can make sure that that has been signed by us, that has been signed by the respected authority that has been shipping that particular thing. And then you can basically work on top of that, rather than just pulling an unwanted, unauthorized model onto your machine. So yeah, that's the model. I also have few, I can say, reference through which I basically was working around creating this particular presentation. One was like a white paper which was published by OpenSSF. Another, I also have a course around, we also have a course on Sequent AMS supply chain. It's kind of beginner-friendly course where you can also go through and understand more about how things work. There are a few demos that you can play around. And there is a research paper which was been published by Google, which I have listed over here. In addition to that, is a project that I talked about, KitOps. It's an open source project which comes under CNCF, the sandbox projects. So yeah, thank you. If you have any questions, yeah, we have some minutes, we can address that. And yeah, thank you.
Yeah, I just have a few questions. I don't know if you've done this or not, but the first question I have is, and I'm kind of reaching back in time to when I last really looked at this in detail, but when you're talking about a model, you're talking about something like a, what do you call it, the TensorFlow structure that you've inputted training data in, and now you've got a bunch of weights that are inside that TensorFlow. So are you analyzing those weights statically and analyzing them with the model scan tool?
Yes.
And so, trying to understand how that model could, operate, I guess, or, its outputs?
So in a way, model scan, whenever we scan model scan, it tends to scan each layers of that particular model. And based on that, it provides an estimated result to us. So if we talk about weights, I'm not sure how that particular thing works, but in a way, it processes the layer in one format after one another and tend to provide us the result. So at the time of deserialization, when pickle file tends to get pulled into our machine, it tends to scan at that level, like at that time of when the model is on a disk, and that basically provides the result. And then further, whenever we tend to ship it or I can say ship it or to a Docker up, at the time of serialization where the pickle file is again basically used, at that time the model scans and then provides us the output. This is how it basically works.
Okay. And then have you ever looked at tools, like in classic UIs where you have inputs from people, like I'm thinking of, you might have a chat bot in the case of ML here, where people are inputting and then getting outputs. Have you ever looked at basically fuzzing tools for ML, where you fuzz the inputs into the ML and then see what the outputs are and see if they're within the acceptable outputs that you expect?
No, not yet. I have not tried working around that. But I guess there is one project at last which is which has been worked by Intel, and they are working around this particular thing where they are trying to secure the entire, I can say, they are trying to secure the entire supply chain from data processing to end goal. So they basically are working around the use case that you basically, the problem that you basically talked about. So that's a project that you can look upon. But still, it's a developing thing by Intel, but it's open source.
Oh, it's Intel that's doing that?
Yeah.
Okay. And what is it called again?
Atlas, ATLAS.
ATLA.
Yes.
Okay, Atlas. All right. And then I guess one other question, and I'm not sure if this is really valid for ML, but in a regular piece of software which is running code or binary or whatever, you can attach a debugger to it and possibly step through, maybe not the source code, but maybe at least the assembly code. Is there anything equivalent for ML where you can step through how it is doing its logic? In other words, debug it in a sense. Is there any debuggers available for ML?
No. Up until now, there is no tool which is currently working on that particular skill. No.
There's no way to do that.
As per my understanding and the research paper I went through, it's still an, I can say, developing phase. But people are still developing and trying to find out ways they can provide a valid solution. because this was not there like 2 years ago, and there has been limited, I can say, work around this. So not sure about any project which is working on that debugging scale part. But
All
there
right.
may be some, not sure about that.
All right, thank you.
Yeah. Thank you.
This doesn't work so well for short people. A few questions. Number one, is any model maker generating AI bombs or not?
Any?
Are any model makers generating AI bombs?
Yes.
Do you know which ones are?
Like there is BOMCTL, a tool that is basically used to create, to work around that, to create AI bombs for any, I can say, model that as a user I can create.
Right.
That's
So-
a tool, and still developing, yeah, that's a tool.
So I would run the tool
Yes.
then? Oh, okay.
You can also automate that using a CI.
Gotcha. The CA authorities for the
Model
signatures,
signing.
are they just like VeriSign or somebody like that, or is there special CA authority for those signatures?
I guess it's the CA I'm talking about, Flushio. It's a subcomponent, and it's been hosted by the community, like Sixto. And it's not like it's public, but as a user, as an organization, they can also privately host that particular authority. So you can also have control on your certificates and authority that you have. So it's both way, where you can basically make use of public, I can say, registry, or you can host that in-house in your cluster, and then make use of that. So it works in both way.
Okay. And then your ML, secure ML chain that you showed the slide on, it seems to solve all the problems except the data poisoning one.
Yep.
Okay.
Yeah, I also had that. Yeah.
Thank you.
Thank you.
Related to that, I apologize if you covered this. I was a little bit late coming into the session, but looking off the left of your diagram you had previously, wrote your flow. I see that you're looking at certifying and signing and validating everything, but off the left end, the training. I saw that you have model cards might have what it was trained on. Is there any way that's currently being certified to say, hey, I know this was trained on licensed data or those kind of things, so that I know the model that I'm using was trained ethically, for lack of a better term?
Can you repeat again?
So if I download a model from Hugging Face or Google or wherever, and it's got a model card, and it says this model was trained on XYZ, is there any way that is certified to say this was trained in that manner and it's ethically and that has been signed to be as such?
So if I repeat your question again, it's like whether we can verify the data set. So I can say data which has been used by that Hugging Face model who has a model card. Is there a way we can authenticate that?
Yes, exactly.
No.
Okay.
As of now, no. There is no idea around that. Yeah.
Thank you.
So yeah, thank you everyone. I hope you had some great session and around this. Yeah.